Hey everyone, welcome back to NeuralTensors. Today we are diving into machine learning from a beginner's perspective. We'll explore what it is and how it works, and build a simple but powerful linear regression model. Using real-world height and weight data, we'll visualize the relationships, fit the model, and make predictions. By the end, you'll have a clear understanding of how machines can learn from data to make informed decisions. Stick around, it's going to be an insightful journey. Let's take a moment to break down the core concept of machine learning. At its heart, machine learning is a branch of artificial intelligence, AI, where systems can automatically learn and improve from experience without needing explicit programming for each new task. For example, when you use Google search, it learns from your past queries to suggest better results over time. Or when you watch videos on YouTube, the recommendation system predicts what content you might enjoy based on the patterns from the other users. It's all about recognizing patterns in the data. In this video, we'll focus on supervised learning, where the system is trained on level data, meaning we provide both the inputs and the corresponding outputs, and the machine learns to map one to the other. Now, one of the simplest and most widely used models in machine learning is linear regression. But what does that mean? Imagine you have a set of data points that show how two things like height and weight are related. Linear regression helps us to draw a line through these data points that best explains the relationship. This line is useful because once we have it, we can predict one variable, say weight, based on other variables, say height. The idea is that by learning from the past data, the machine can make prediction about new, unseen data. Here's a simple analogy. Imagine you have a group of people and you know their heights and weights. If we plot their heights in one axis and their weights on other axis, linear regression will help us to draw a line through these points. This line tells us if I know someone's height, I can estimate their weight. Of course, not everyone will lie perfectly on the line, but it's a good approximation. Alright, let's put this theory into practice. We'll start by working with real-world data of heights and weights of 15 individuals. Our goal is to create a machine learning model that can predict someone's weight based on their height. We'll walk through every step, starting with visualizing the data and ending with making predictions. Here's the dataset of 15 height and weight samples we'll use. Notice that while there's a clear trend that taller people generally weigh more, the relationship isn't perfect. This is typical in real-world data where many factors can influence weight beyond just height. This data is a more realistic representation because not everyone's weight is exactly proportional to their height. The variation in weight reflects other possible factors like muscle mass, lifestyle, or diet, which are not accounted for in this simple model. Before we build the model, let's first take a look at the data visually. Plotting it will give us a better sense of relationship between height and weight. So let's go to Jupyter Notebook. Here we're importing two essential libraries. NumPy is a powerful library for numerical computations, and Matplotlib is what we'll use to create visualizations like scatterplots. Next, we're defining two arrays, one for height and one for weight. These are our real-world data points where each height corresponds to a specific weight. We'll use these values to build and visualize the relationship between height and weight. Now we use scatter to create a scatter plot. This function will plot each height-weight pair as a dot on the graph. We label our axis and add a title to the graph, x level and y level. Then we use plt.show to display the plot. Next, we import the linear regression class from scikit-learn's linear class module. This is the machine learning algorithm we'll use to fit a straight line through our height and weight data. Here I'm reshaping the heights array Scikit-learn expects the input to be in a two-dimensional array format, which is why we use recep. The -1 means it automatically calculates the appropriate number of rows, while 1 specifies that we want one column. Our target variable y is the weights array. It doesn't need reshaping because it's already in the format scikit-learn expects. Now we're creating an instance of linear regression model. Think of this as an empty machine that's ready to learn from the data. And this is where the learning happens. The fit function takes the height values and the weight values and it trains the model. Essentially, it finds the best fitting line that maximizes the error between the actual weights and the predicted weights. After fitting the model, we extract two important pieces of information, the slope and the intercept of the line. The slope tells us how much weight increases for each additional centimeter in height, and the intercept is where the line crosses the y-axis. And finally, we print out the slope and intercept to see exact values. These two numbers define the equation of our best fitting line. Now that we have our model, let's use it to predict the weights for each height in our dataset. The predict function applies the equation of the line, which the model has learned, to every height, giving us the predicted weights. We plot the original data points again using scatter to visualize the height and weight pairs. Here's the magic moment. We plot the best fitting line that the model has calculated. We use plot to draw a straight line based on the predicted weights and color it red so that it stands out from the data points. We add labels and legends to explain what the red line and the blue dot represents, and a title. Next, we want to predict the weight of a person who is 180 centimeter tall. To do this, we create a new numpy array that contains the value 180. Notice how we put it inside the double brackets to ensure it's in a 2D format. We then use our model's predict function to estimate the weight based on this height. The model uses the line it learned to calculate the weight that corresponds to 180 centimeter. So finally, we print out the predicted weight, rounding it to 2 decimal places. This gives us an idea of how well our model can generalize to new on-scene data. So in this video, we explore the basics of machine learning using a simple yet practical example of linear regression. We use the height and weight data to train our model, learned how to plot and visualize the data, and made prediction with the real-world application. This is just the beginning. Machine learning has endless possibilities and applications. If you enjoyed this video or want more tutorials, don't forget to like, subscribe and hit the notification bell to stay updated on more machine learning content. Thanks for watching NeuralTensors.